Hello, my name is Jordan Schaefer, and today I would like to tell you about my work on a project for a local entrepreneur regarding toilet seats. My technical advisor is Dr. Wang. So, a little overview of this presentation. I'm going to go over the background of this project, as well as the actual problem that I've been trying to work on, the engineering design, the methods and testing that I used, and then finally we'll end up with a business case and some recommendations and future work. There's a local entrepreneur named David Dieter who noticed that there were some issues arising between different genders because of the way that they use the bathroom differently. Men often leave the toilet seat open, and women often leave the toilet seat down. And unfortunately, this has caused disputes. He's also noticed that gender-neutral bathrooms are becoming more and more popular these days. And because of this, the opportunity for disputes has only gotten greater. So having to open it, and additionally, having to open or close a toilet seat with one's hand is unsanitary. And with gender-neutral bathrooms gaining in popularity, the problem of needing to touch an unsanitary toilet lid is only enhanced. A local entrepreneur has an idea for a product to fix the aforementioned problem and needs the product to be designed and tested. In order to better understand the underlying issues of this problem, I performed a thorough literature review. And in this literature review, I looked at a variety of different sources. Some were looking at sanitary issues regarding touching a toilet seat, the spread of diseases and bacteria from person to person when they raise and lower the toilet seat. One of the design ideas is to use some sort of pedal system to open and close the toilet seat, so one doesn't have to touch it with their hands. So I looked into different types of pedal systems or pedal designs and locations on other products and how those pedals were designed. Something I found that was sort of surprising had to do with toilet seat injuries and toilet seats falling and hurting people. And I think it would be really cool if this product could help with that problem. And finally, one of the early designs that I was thinking about incorporated the use of plastic gears. So I did some research on plastic gear design for my literature review as well. Another thing that I really looked into were different patents. So the entrepreneur that I'm working with was not the first one to notice this problem, and other people have tried to come up with solutions for how to easily raise and lower a toilet seat hands-free. And so I looked into some of those patents, and those patents kind of fall into three general categories. First patent category I've called motorized systems. And as you can see from this picture here, here's an example of one. The pros of motorized systems is they're generally pretty aesthetically pleasing and easy to operate, but unfortunately they can be pretty high in cost. Their durability can be low because they deal with electronics around water, and there's just, because they're so complicated, there's many pieces that can break. And then finally, they need a power source. So that could either be a battery, but batteries are expensive and need replacing or recharging. And the other option would be a power outlet. But then you need a cord going to a power outlet, and power sources aren't typically near toilet seats. So I don't think that's the best option, although there are people who have tried to come up with designs that utilize motors. The second type of option is pneumatic option. And these tend to look like they'd be pretty easy to operate. However, they don't look very good, and which is a big problem. Nobody's going to want to put something in their bathroom that's big and ugly, and they tend to be a little bit complicated, and also they tend to have some problems with mounting. As you can see from this picture here, how it's mounted to the toilet seat. You either have to use some sort of glue or sticky substance, or you'd have to permanently damage the seat by drilling into it, and that can pose some problems. The final type of category that these patents are in, I like to just call the lever category. And the pros about these is they tend to be simple and cheap to make. But as with the pneumatic system, that you can have some issues with mounting, as well as having issues making them fit with multiple different types of toilet seats. But after looking into all these options and talking with the entrepreneur, we really thought that cost was the item that we wanted to keep low in order for this to be accessible and as many people to be able to buy it as possible. We wanted to keep the cost down, so we decided to go with the lever system. So now moving on to the initial design. The first design, as you see from this picture, is simple. This is the base for the initial design concept. It has this lever that when you press down on it, it turns some gears which rotate a cylinder. Now this cylinder has a cable wrapped around it that goes up to another mechanism that I'll show you in the next slide. But this was the first design, and it's pretty simple to see how it works. What's nice about this is that this doesn't have to be placed right underneath the toilet seat, so it can be placed kind of forward or backwards, and then the amount of cable that's pulled in or out can be adjusted by the throw of the lever arm, as well as the number of teeth and the radius of that cylinder in the middle. And because it uses a cable, it can be adjusted easily for many different toilet seat heights. So the cable will go up to this other mechanism, which mounts underneath one side of the toilet seat bolt. And this consists of a couple parts here. It just has the mounting bracket, a bearing, and then this lever arm, which the cable goes up and attaches to. And this will, the lever arm goes underneath the toilet seat, and when the pedal is pushed down, it will help lift up the toilet seat. Now, after doing some research on the design of plastic gears, I decided that although this concept helps provide that forward and backwards lateral movement, it's a little complicated, and I decided to sort of redo the design for the DFM DFA redesign. So this is the new design that I've come up with. It's much more aesthetically pleasing, and you can see this part, it has less pieces, so from an assembly perspective, it's going to be easier to assemble. This only has 3 pieces as opposed to 5 or 6 for the other base. So you see this has a nice textured pedal for grip, for it's easy if you're in bare feet or you're wearing shoes. And then this has been designed for injection molding, so everything is ribbed and all the sections are thin and drafted as well. So after the DFM and DFA redesign, I decided to test this product, and one of the ways I did that was through injection molding flow simulations. Decided to use ABS because it's durable and cheap and readily available for this simulation. And as you can see, some of the volumes and temperatures there that were used in the simulation. The simulation was extremely helpful. It showed me where the weld lines were, and that helped because I was able to ensure that where I placed the gate was in a good location so that the weld lines wouldn't be in high stress areas or areas that were too visible. It also helped show where the sink marks would be and how much it would sink in certain locations, so I could adjust the thicknesses of certain sections, as well as the temperature of the material and things like that, and the rib design to minimize the sink marks. And I did that for both the base and the pedal. After ensuring that everything was good with the simulation, I 3D printed a prototype and was able to mount it to a toilet seat and use it. And it works the way it is now. As you can see from this video, when you press it down, the toilet seat opens, and it's been designed so that the toilet seat opens not completely, but just to the section where right before it opens all the way. That way, when you take your foot off the pedal, it will close, and you won't have to reach out and touch it with your hand. So the business case, I've gone over the cost to manufacture, and I will have a detailed estimate for how much it's going to cost to manufacture each of these pieces, as well as an initial investment estimate, how much it's going to cost to kind of start creating these, and then an estimate on how long it'll take to to get a return on that investment. For recommendations of future work, there are a lot of social and environmental impacts. This product kind of came about because of a social dilemma between genders who use the bathroom in different ways, and kind of the goal of this project is to help with that conflict. But there are other issues. Because this is being manufactured, it'll probably be manufactured somewhere that's not in America. You gotta be trying to think of issues such as work environment for people, and make sure people are getting paid and treated fairly for something that it would ideally be mass produced. There are also environmental issues. We use ABS for this product, but a more environmentally friendly plastic could be chosen, which might be a little bit more expensive, but the pros and cons could be weighed for that, and the plastic could be changed easily enough, and it could be more environmentally friendly. For future work, I think that this product needs some sort of locking mechanism so that you can lock the pedal down in the down position. That was kind of out of the scope of this project, but that would greatly improve the usability of this. Additionally, something else that is not as needed, but I know talking with the entrepreneur for this project, he kind of wanted some sort of soft close mechanism, and while I think that would add too much cost, it is something that could be looked into. I did not research that at all to see how feasible that would be.